Hey guys, got some questions regarding coin flipping and how to represent that in code. Quite a few questions actually about it. And so what I wanted to do, I wanted to chime in and just kind of break that process down and get your mindset kind of thinking around this sort of methodology. And so what we have basically is imagine a coin right now. It's two sides, heads, tails. And if you're some extreme lucky, you might hit the edge, but we're not worried about that. We're worried about heads, tails. And so there's a couple of ways that you can think about this here. The issue that comes to mind with generating this is that you're trying to induce something that's random. When you break out a coin and you say, let's take a toss at it, what you're doing is you're saying, let's decide with chance. Let's flip this coin and let the random result prove the victor here. So what we're trying to do is we're trying to simulate that in code, but hey, here's just a real quick heads up. There is no way for the computer to randomly just generate numbers. It can't just randomly pull this out. So basically what we have to do is we have to simulate a pseudo-random sequence here. And that's, that might be a little hard to wrap your head around here, but yeah, the computer cannot be random. It is calculated. And so you even think about things like, for instance, casinos and other things that leave this whole game set up to chance, and how can they all be computer powered but yet not be random? And the way that this actually works is that you are taking a series of mathematical equations and you're taking a seed, a number, and you put it through this series of mathematical equations and it scrambles it up. And so basically what you're telling the computer to do is to go and fetch a number out of this pool, and it scrambles and chooses a math equation to simulate something that's random. And that's how most of this stuff works. There's a few different approaches, but we won't go into that. So built into here, into C++ that we're going to be using here, is something called rand, which it's a function, looks like this. And what rand does is it's a function that will return a number. It will return a random number. It'll probably be a pretty large number. And then there's another function that goes along with it called srand. And it looks like this. Now what srand does is it seeds the random number generator. It gives it something as an override. Because if you don't give it something as an override, it will just be 1. So whatever it comes back with, it can be very predictable. So by giving it a seed, it allows it to be a little bit more perceived to be random. So you're trying to represent a coin, and a coin has two sides. This random number pool does not return just one number or another. So we have to force it to actually return a number that is between the range of whatever we want, 1 and 2 or 0 and 1. I'm going to choose 0 and 1. Okay, that's going to be the easiest for us to do. And the way that we actually build this equation here is I'm going to create, first off what I'm going to do is I'm going to create a variable. I'm going to create a variable called coin. Now the reason why I'm creating a variable called coin is because I want to be able to report this coin. And I'm basically going to come down here and I'm going to say coin is going to be assigned with the random return of this function call. Now, if I did this, let's just go ahead and see out coin real quick. Sorry, brain is trying to catch up with my hands here. All right, so if we do this, run this program real quick, we're going to see we get back 41. Well, that's not too bad. All right, cool. We still get 41. And it seems to be a little predictable at this point because we keep running it. I'm going to keep getting 41. So, pardon me, I'm getting over a cold real quick. So if I do anything that sounds like I'm dying, probably because I am. So let's seed this random number generator, this rand function, with some overridden seeds. That way it just doesn't send 1 in all the time and we get back 41. You may be getting back a different number. For instance, I'm getting 41. So let's go ahead and do this. Now, what I'm going to be doing is I'm going to be including another library. I'm going to actually be including seedtime. Now, what is seedtime? Seedtime is the way of exposing the system time to this program. So it can go and get the time based off in seconds where we're currently at. Everything is calculated in seconds when we're talking about computing in time. There's actually a master clock that went online in the 70s, been tracking time since then based off seconds. Atomic clock, I believe. Really cool, fascinating stuff to look into if you want to check it out. Alright, so what I'm going to do is I'm going to create a, let's go ahead and create a variable for this here. And the reason why I'm doing this specifically this way is I want you to be able to follow the code and trace the code back to the wall here. I'm going to call this int seed. And I'm not going to stop there. I'm going to initialize this to, and here's where a function is going to come out of this library. There's a function that's built into this library. And you can basically look at any of these libraries. You can pull up IOStream, you can pull up seedtime, you can look at their APIs. API, if you've never heard of that term before, application programming interface, basically what we're wanting to do is we're wanting to look at the manual on how to use this portion here. So you can go and look up the manuals of what is contained within inside of this library and figure out how to use it. You look it up in there, you'll see that there is a function inside of seedtime that allows us to get the time. So if we're going to be doing this here, we might find that time is a function and we can go ahead and call that function and expose seed. Okay, so the only other thing that I need to do to this is I'm going to modify this data type. Now I'm going to modify this data type to not allow negative numbers. Why? Because A, we want to be able to have a data range that only goes in the positive range. We have as many decimal places as possible. By decimal place, I mean to the right. Of course, this doesn't hold level of precision, or excuse me, to the left. But we want this data type to not have the ability to take negative numbers because time is never negative. So we're gonna call this wow, I butchered that. Unsigned int. Unsigned basically will modify this data type so that it will not allow it to take negative numbers. That's all that does. So this is a modifier. So we're going to modify the data type. Now it is a data type that is of type int that does not take negative numbers, and time, there it is. Cool. So then we're going to turn around and we're going to initialize and seed the random number generator. What are we going to seed it with? The seed. There we go. Now I'm going to go ahead and just hit run. And there it is. Look at that. We're getting numbers now. Okay? Cool. Alright, so it's changing and it's incrementing. Now, for those of you that can see the pattern, it is incrementing based upon the seconds of time that it's currently at right now. And you will just see it slowly increment. But we're not worried about that right now. We're going to keep moving on. How do I get that crazy large number, that 2,000, I don't even know what that was. How do we get that down to either be a 0 or a 1? Here's the answer. You're going to use the modulus operator. What does the modulus operator do? It's the only operator that isn't inherently obvious what it does. What modulus does is it says, go do division between this number and another number. And after that number is divided by, I don't care what the result is, how many times it went into this number, just give me the remainder. Just the remainder. So how many places, how many number places, you imagine a number line, say from 0, is it to 0 to 1? We have two number places. We have a 0 or a 1. There's two possible number places. So what if we went with a modulus 2 here? So modulus 2, and then we just hit go. All right, we're going to simulate, we're going to run this program. Okay, I see a 0, see a 1, see a 0, see a 1. And I see it flipping back and forth. Let me tell you what's going on behind the scenes. You take this crazy high number, divide it by 2, what are you going to get? You're either going to get a 0 where it divides in evenly, or you're going to get a 1 where it's left off. Because if it was 2, it would go into that number again. Here's just a quiz. What if I wanted a number between 1 and 10? Between 1 and 10. Well, if I wanted between 1 and 10, I would do it by 10. Now that's going to give me 0 through 9. 0 through 9. So how do I get 1 through 10? Well, I need to offset it. If I just added 1 to the end of this here, that would offset it. So I would originally get 0 through 9. If I just add 1 to that, it would then be ranges 1 through 10. Observe. There's a 3, 10, another 3, so on. I'm running this in the background, and I don't know if you guys can actually see it when I compile. You might not be able to see it when I compile just because of this crazy monitor setup. But if you're not seeing it, just basically take this code, run it, execute it, and you'll see the result. Okay, so this would give you 0 through 9, but again, we're not after that. That was just for demonstration. We are after 0 and 1. Now, the hard part of this assignment is actually taking a 0 and a 1. This is the landmine. This is where I want to see your brain work. I want to see you take a 0 or a 1 and map that to either meaning heads or tails. And it doesn't matter which one you pick. Say 0 is heads, 1 is tails. You need to take that, and you need to take that thought process, and then you need to map that to a meaning. So basically here, you need to ask if coin is equal to 0, it's heads. Now, this is not actually what I'm having you do. I'm just printing this out. Okay? It's heads. All right? Now, what if you picked heads? Okay? Cuz here's what you need to do. Here's what you need to do. You need to create a character for the user choice. And this is where mapping the two types of data comes into play. You have a char and you have an int. How do you take an h and how do you say if the user picks a 0, that's h? How do you do that? Well, there's a little bit of conversion that needs to go back. And, you know, it goes back to the whole concept of functions. Now, the concept of a function, I want you to think of a function like just this household appliance. You stick something in and out comes a result. Think of it like a toaster. Okay? So, if you stick a char into this toaster that you build, you need it to convert into a number, a 0 or a 1. We'll say, okay? So, what if you made, and I'm not going to write this function out because this is where your brain needs to work, but what if you had a function that returns an integer? Okay, it's going to return an integer, and you can call this whatever it's supposed to be in the instruction sheet, but what if you had it as evaluate? And what if this function returned something, okay, and it took a character, we'll call this one choice, call it X, call it whatever you want. What if this setup was like this? And basically, once you get back to your program, what if we could take those two numbers and then compare them? So what if we had an int called results or something like this? This is just, hypothetical stuff we're throwing out here. And we had evaluate being sent choice, or sending choice into evaluate, and we have result going to be stored with the return of that. You guys see where I'm going with this? Hopefully. We can then consider if coin and result are the same, we won because we picked the same number. For instance, if I pick heads and it comes back heads, I win. Now, here's what I do not want to see. And if you already submitted your assignment this way, then redo it. I do not want to see a permutation of every possible outcome. What do I mean by a permutation? I mean, I don't want to see if the coin was heads and the user picked heads. I don't want to see if the coin was heads and the user picked tails. Basically, every type of combination here, every possible outcome, a permutation of every outcome that is possible, which is 4. There are 4 possible outcomes in which I can pick one of the two sides, and there is one of the two sides. 2 times 2 is 4. Okay? So, with this in mind, if the coin and results are the same, we win. Else, you lose. Now, this isn't the assignment. The assignment has you do a little bit more. There's a betting system, and you take money away. This is a big, lengthy problem. Why is this so big and lengthy right now? As I'm trying to get this drilled into your guys' head. This is going to make you strong and elite. If you can get this concept down, I'm telling you, you can walk into places and problems just start solving themselves before you even write code. You're going to be able to see things clearly and organize. So, I have not actually written out the functionality for this, but I think this gives you enough to give you a head start on how to flip a coin, evaluate it, and then send that into maybe a function that converts it over. So you're going to need to do this. And then when it comes back, evaluate. Send it. You can write this into a function if you want and send it off and say, hey, go figure out if I won. Report that. There's a lot of possibilities that you have here. So I'm going to go ahead and end with that, and hopefully this opens your eyes into a way of wrapping your head around this assignment. Good luck, and let me know how it goes.